All right, welcome everyone. I am JJ. Let's tackle another example problem. So this time around, we're working with a truss problem, and we're trying to figure out what's going on in members CD and DK of our truss. So let's just come and mark those off. CD and DK of our truss. I would tackle this using method of sections. Is almost always, if we're just looking for a couple things, going to be the easy approach for us, especially in a bigger truss like this. And I could get a section that slices through both of those if I just go vertically straight down the middle of this, where we can cut up to 3 unknown members, because those are going to be our 3 unknowns in our equilibrium equations. So if I go straight down, I'm cutting member CD, member DK, and I also cut through KJ. It's going to have to show up in my free body diagram. But then I get the option. Do I want to include everything off to the left of this, or everything over to the right of this? And it's kind of just a toss-up. I'm going to do my free body diagram to include everything off to the left. So if I set that up, let's draw in all of our uncut members. So I go from A all the way over to K. I go from K all the way up to the top of the truss. And then I diagonal back in here like this. So we have those members. I also have a diagonal right here and a vertical piece right there. At A, I have my pin, and I'm given my support reactions. AY was 34 kilonewtons going up. That just helps speed everything along. AY was 34 kilonewtons. I also, at that point, have an AX, and I was given that, 2 kilonewtons to the left. 2 kilonewtons. This is like a homework problem. You would have to come in and find those support reactions. That should probably be your very first step for these problems anyway. But we're giving it just to save time. 2 kilonewtons to the left. I know in point L, I have 9 kilonewtons going down. 9 kilonewtons. And at K, there's 20 kilonewtons coming down. 20 kilonewtons. I also know going up this, if I go up, it is 6 meters. I get to, there's a force right here going to the left, going to the right of 8 kilonewtons. 8 kilonewtons. And at the very top, which is 12 meters tall, I get to a 10 kilonewton force, this time actually going to the left. 10 kilonewtons. And then I start getting my cut members. Well, let's label, these are each 4 meters wide. 4 meters, 4 meters. At the bottom, coming out from K, I have, let's label K. I have my first unknown force, FKJ. FKJ. And I have a force going up and to the right in here. Up and to the right. I have member FDK. FDK. Now you have to find the angle that goes at. So we'll call that theta. And then up at the top, coming out from, that's point C, assuming tension. So going down and to the right along the member, I have the force in CD. CD and DK are going to intercept up here at point D. And if we use that, we want a distance in here. That should be 9 meters up from the bottom of our truss. But so what do I need in here? I have 2 unknowns I need, 3 on here. I don't have to find FKJ, but if we found it, it's not going to hurt us. It might make our work easier. But how could we do this one? If I were doing this, I would come in and say, why don't I just sum moments here at point K? If I do that, I'd eliminate DK, KJ, the Y component of CD, this 20 kilonewton force, but FCD is my only unknown there. As soon as I find FCD, I can just sum forces in the Y and get FDK out. I can wrap this up in 2 equations from here. So let's do moments at K. So with positive, going counterclockwise, summing my moments up about point K. Should get me to, my 9 kilonewtons will cause a clockwise rotation So I would have 9, negative 9 times 4. Sorry, I'm looking at the wrong point. It would cause a counterclockwise rotation about K. I was looking at A. About K, it'd be counterclockwise. So positive. Force is 9. Distance is 4. I would have my 10 will cause a counterclockwise rotation. So plus 10 times 12. My 34 will be clockwise. Minus 34 times 4 plus 4, 8. Minus 8 times 6. Minus 8 times my distance is 6. Minus, I didn't label an angle on here, but it goes, if we count that off, CD goes over 4, and it drops down 3, from 12 to 9. This is 3, 4, 5. 3, 4, 5 for our triangle in here. So the y component doesn't cause moment, just the x component, minus, because it'll be a clockwise rotation, the x 4/5 of FCD times a distance in here. From the top to the bottom, 12. 12 is going to get us to 0. Equals 0. Solving for FCD, we're going to get that it is negative 17.08 kilonewtons. That's negative when we assumed it was in tension. That means we're really in compression here. So we report as a positive and say compression. FCD is a positive 17.08, 17, not 11, 17.08 kilonewtons in compression, which is our first answer. Again, with FCD known, I have one unknown left. All right, 2 unknowns in my free body diagram. I only have to find FDK for this problem, though. So let's just sum forces in the y. If I sum up my forces in the y direction, I'm going to get 34. I'm going to get minus 9. I'm going to get minus 20. And I'll add in FCD's y component because we know it's really going up. So plus 3/5 of FCD, 17.08. I got the 9, the 20. All we're missing is our FDK. Which to get that in, I should pause. Let's find theta. Theta is my inverse tangent of opposite over adjacent. DK goes up. That'll be my opposite 9. And it goes over my adjacent is 4 meters. 9/4. Or my theta is 66.04 degrees. With that known, I can put that in with my angle in here. 3/5 of 17.08 times, or not times, my next one, FDK, my last unknown, plus FDK sine theta, sine 66.04, gets us to 0. Which if I solve for FDK, I get that FDK is negative 16.69 kilonewtons. That negative means we're in compression here. FDK is really 16.69 kilonewtons, and we are in compression. Which finishes that problem. I didn't have to find FKJ. I could have gotten it. Wouldn't have hurt us. I wouldn't have marked a student down if they did it. But it wasn't necessary. So save time and move on. Especially if this is a test. But we'll go ahead and wrap up there. Hopefully this was a useful video for you. If it was, hit those like and subscribe buttons. Watch more videos. Let's get you in A with JJ.